Okay, so good morning, everyone. So I will be giving a brief overview on how we can use machine learning technique called clustering for optimizing laboratory testing. So in a typical laboratory testing campaign, we can do a fair amount of basic index testing for profiling, but when we move on to more advanced testing, like for example triaxial, due to budget and time constraint, we can only do a much more limited amount of tests. And so obviously we want to make the most out of this test and test samples which are representative of a site. And I think that's where clustering method can help. So it's a family of algorithms which try to find pattern or structure within the data, and in particular try to group together data points which are similar. And you have like a dummy example on the right on how the algorithm may work this out. So in this presentation, we're looking at a method which is called a Gaussian mixture model. This method and many others are available in open source Python library. And that's why, in my view, the most important part of the analysis is actually preparing the data for the input into the algorithm. That's where the geotechnical inputs come in. So in our case, we were looking at a stiff clay, a glacial and periglacial formation, which is quite typical of Northern Europe. And so we selected 3 parameters which are relevant for clay, so moisture content, build density, and endurance strength for pocket penetrometer, which were also all available at the end of fieldwork. So the data is plotted on the right as pairwise plot, and the diagonal you have a distribution of each individual parameter. So once you've selected your parameters, typically you need to do some cleaning of the data, and then another important step is applying some transformation or pre-processing of the data. In particular for clustering, scaling of the input parameter is important. So once we carefully prepare our data, we can run the algorithm, and this is the kind of output we got for our stiff clays. So we can see that the algorithm was able to detect this low strength, high water content material in green, which actually corresponded to a layer in one of the borehole. Then we also had a high strength, low water content material in purple, which was found in this borehole and in others. So hopefully this shows you that this method provides like a useful visualization to identify zones of similar material and then select your representative sample. Obviously this is to be used in more conventional, along with more conventional method, like looking at the log, the picture, and the geology story. And there's much more detail in the paper, and or you can come to talk to me at the break as well if you're interested. Thank you.